and I'm going to pose you some problems. And for those who have a machine, have a computer with which you have recourse to egrep, I would suggest that you fire that up. Okay? So, folks, I'm going to have a reg expression to identify one or two digit numbers that lie in the range of 0 to 99. We'll assume, incidentally, that it's fine. Whatever they're preceded by is fine as well. So, for the moment. So what would we do if you wanted to identify one or two digit numbers in the range 0 to 99? Boop.
So imagine
This is presented. Where would you start? Okay, good. So we'll use grep, and suppose we want to identify lines which contain, one or two digit numbers in the range 0 to 99. And at first, suppose we don't care that much about context, but they're preceded by whatever. What do we look for? Okay. Yep. Okay. Okay. Okay, so a lot of good ideas there. So how would I identify, so let's break this down into pieces. And this is a lot of what this lecture is designed to try to help communicate. When you start with a problem like this, eventually you develop an intuition for how you might be able to approach it as a whole. But first, it's best to break it down into pieces. What are the individual pieces we match? So here we're talking about one number, range 0 to 99. But to match a number, we could do worse than to match a digit. Right? So how do we match a digit from, say, 0 to 9? Sorry?
Square bracket 0 to 9.
Okay, square bracket 0 / 9. Could anyone give me, again using square brackets, another way we could sort of recognize a number from 0 to 9?
Square bracket,
Okay. So depending on the syntax of grep, there are cases where there's special notation for digits, such as \d, which will allow you to do that. And sometimes it's indicated with a colon. But what's another sort of much more simple way? If you didn't know you could do 0 - 9, what could you actually do? Yeah, you just do bracket, open bracket, open square bracket, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And square bracket. Right? Works. It's got a brute force, but there's only 10 of them, so it's not that bad. Okay, so that's great. So that will recognize one digit. Now, how if we wanted to recognize two digits? Sorry? Okay, so if we added a star, if we put a star after those brackets, what would happen?
We could none of them or infinite number of them.
But it could match 0 of them as well, right? So we have to be careful. So how do we match exactly one of them? Okay, so question mark would be 0 or 1. If we want to match exactly 2, what's the way to do it? Okay, well, we could either put them in a row, or we could put in a curly brackets this, for example, 2. In this case, we've done 1 or 2. Okay, so here we could do the first of these, which is saying repeat this 0 to 9 thing one or two times. Either one of those is fine. So it will match 0 to 9, or 0 to 9, followed by 0 to 9. Right? The second one does something very similarly, but with the operator suggested, so with the question mark operator. So it's definitely matching the first one. It needs to match the second one. And it'll match excuse me, it needs to match the first one. If it matches the second one, it's possible. That's what the question was. It may or may not be able to, and that's okay. It's optional. Okay. So here, we feed this 0. By the way, you can ignore there's something that's screwed up about the indications of these closed brackets of many of these, so you can ignore the fact that they're twisted in a different way. So if we fed it 0, for example, would it match? Is this matching 0? Yeah, it's printing 0 after it, so it's matching. We can give it 99. Will it match 99? Yeah. Will it match -1? Yes. Why does it match -1? Doesn't care about the minus. Because we haven't told it that it can't be preceded by anything. It's just trying to look for it somewhere in the line. We can precede this if we wanted to by invoking the name of the line. Cat-a-tat-tat. Or maybe it's cat-a-tat. And then follow that by 1. Would that match? Ladies and gentlemen, if I had cat-a-tat followed by 1, would it match this regular expression? Ladies and gentlemen, let us go compute. So if we were to do, well, let us not compute. Let us crash. Okay, so let's rescue this, and then we can pursue cat-a-tat. Okay, so I'm going into bash. That will allow me to use this sort of syntax, and then I'm going to do egrep, and why am I putting these in single quotes? Okay, I want to give a pattern. I don't want that pattern to be interpreted by what? By the shell. If I didn't put in there and I had this, it's going to be looking inside there and trying to twist it to its own interpretation. So if I want to have this, for example, and I want to see if that matches the string 0, yeah, it matches 0. Will it match cat-a-tat 1? Yes. It doesn't care about the cat-a-tat. The lion may be impressive, but it's impartial for it. It really doesn't care for it. All it's looking for is this expression saying, does this expression match somewhere in here? We haven't told it at the beginning of the line, the end of the line, it's surrounded by non-word characters. We haven't said any of that. So it's just looking for it somewhere in here. And yes, at the end of the lion's name, the end of the line of the end of the line we see a 1, so it does match. Okay. Does that make sense to people? Okay. So that's good. Will this match 199? Yeah. Will it match that? Absolutely. It's looking for it anywhere in there. Okay. So suppose now we wanted to, I'm going to skip forward a bit. Suppose we wanted to have this only be surrounded by things that are not numbers. So we don't want numbers that precede it or numbers that follow it. We only want to match a number, a series of digits, that has either 1 digit or 2 digits, no more, no less. Okay, so tell me how to do word. Okay, so one option would be to do a -w. So let's try the -w here. And will this work? No. Okay. Will this work? Good. This? Okay. And 0? Yeah. How about this? No. Remember, we're dealing here with strings of characters. It doesn't care that 0, 1, 0 in base 10 is the same as 10. It doesn't care about them. It's the same as 10 in any case. But it's the number 10. It doesn't care that. It doesn't care about that at all. This is just a string of characters. And that string of characters is not, it doesn't include something that's a single digit or two successive digits surrounded by non-word characters. Every two digits defined has either before or after it another digit. And so it doesn't match this. Okay? It does not match that. Now, there's a more flexible way we can do this. This is a convenient little component of grep, but the more flexible way is to use these sort of matching graphs. These are a little bit confusing. I described them in one of those videos. But basically they insist that whatever's in that pattern be surrounded by something that, again, is not alphanumeric. It's not A through Z, either capitalized or lowercase or capitalized. It's not 0 to 9, and it's not an underbar. It could be the beginning of the line. It could be the end of the line. It could be, other things like a star character or a exclamation point or whatever. It just can't be so-called word, which are defined as being the alphanumerics and underbar. So here, we can use these delimiters of sorts to do these sort of matches. And here we're matching, and you notice it's not matching this 199 is not matching 99, and it's not matching 0. You notice it does match -1 because the minus sign is not counted as being alphanumeric. We can handle that separately. I won't go into it here. Okay. Fair enough. We've now written a regular expression to recognize this, and it rules out things that have more than those number of digits. Okay. We're going to go on now.